first polynomial. Next one, square the last one. And take this times this. 6 times s is 6x times 2. Okay, there's my answer there. Next one. We cannot do just a third like we did the square there. So we have to take 2 of them and then take it times x plus 3 again. So these 2 squared together would be x squared plus 9 plus 6x. And then take that times x plus 3. So x to the third plus 3x squared. This one plus 6x squared plus 18x plus 9x plus 27. Combine like terms there. Enough to get your juices flowing, right? Mm-hmm. Yay. Mm-hmm. All right, so in this first chapter, we're going to talk about modeling and, equations, inequalities, and modeling, mathematical modeling. Determining if a solution is right. When determining if a point of a solution is for the equation, replace the variable with the number that you have and make it a true statement, then see if it's a solution. So here is 2, 13 a solution. Okay, so 2 being x, 13 being y. I'm going to replace those with that. When I do that, I just put the numbers into the x and y terms and see if it's equal. Okay, so y is 13, it says. 10 times 2 minus 7. Okay, so 13 equals 10 times 2 is 20. Minus 7, yes or no? 20 minus 7, is that 13?
Yep.
Yes, it is. So 13 is a solution for that problem. So my answer is just yes. Okay? Whoops. Same thing is -1, -3 a solution. Okay? Now I've put it in. Say again. I've put it in here. -3 equals 10 times -1 minus 7. That's -10 minus 7. What's -10 minus 7?
-17.
-17. Does -3 equal the same as -17?
No.
No.
It does not. So my answer there would be no then. Okay? So that is just what you would do if you're determining the solution. Okay, how about sketching a graph? When we talk about sketching a graph, you remember, I hope, that y equals mx plus b is the slope-intercept form. Where m is going to be my slope and b is going to be my slope-intercept, or where it crosses over the y line, y-axis. Okay? So when it comes to doing y equals -3x plus 2, that's all I have to be able to draw the line here. So -3x plus 2, we go up to the plus 2, because we know that's where it's going to cross over that line, put a dot. Then -3 tells me I go down 3, so 1, 2, 3, and over 1. Remember, whatever form you have, you're going to use it all the time, okay? If you always go down first and then go to the right, that's fine. If you always go up and then go to the left or the right, then whatever form that you are used to. And then obviously we just connect that dot, those dots. Try the second one. 2x plus 1. 2x plus 1. Unless you... Okay, 2x plus 1 means I go up to plus 1. The 2 means I go up 2 over 1. So 1, 2 over 1. And that would be my line there. Remember, I told you a long time ago, function table is not necessary. As long as I have what the slope is, and I have where it crosses over the B or the y axis, I don't need that whole function table. Okay? All right, parabolas. A parabola is an equation that starts with x squared. Unlike where we're drawing the line, it's just y or x. We have an x squared with the parabola. Actually, you may have a y squared as well. If the equation has a variable that is squared, the graph will be a parabola. And in that case, you will need to complete a function table and graph the points of the parabola. If it is positive, the graph will open up as a U. If it's negative, it will open downward. And if you'll turn to page 58, we'll kind of look at that real quick. Page 58 is on graph behavior a bit. You see the parabola there, and you see a table. Remember, one of the biggest things that we talk about is graph behavior, and what would that graph look like if it is like that?
Say that again.
One of the things that we look at the most is the graph behavior and what it would look like if that was our equation. Now let's look over on page 59. On example 4, I see x to the third power. Do you see what x to the third power does? Mm-hmm. It kind of looks like an S, or at least a drawn out S, lengthened S. See the negative x squared down at the bottom of that page, 59?
What do you call that on the exercise 4?
It is not called anything that I know of.
Okay.
A graph. I just call it an S. I don't know that it's just a cubed variable.
Okay.
So you see a couple of the others on page 80. You see symmetry there, which you see symmetry over on 58 as well. Over on 61, you see what happens if you have an absolute value down at the very bottom. Yeah, it looks like a V. Maybe even like a group of Canadian geese there or something. Up on figure 1.5, you see what happens if y is squared on page 61. If y is squared, the parabola lays on its side. Okay? Now, think about what would happen if they were all negatives. What would you be seeing if they were negatives? Maybe a mirror image? If it opened upwards, it would open downwards. If it's laying on its side and looking like this, it would lay on its side and look like this instead. Okay? Okay, so,
Figure 1.6 was absolute value.
yes. You see that blue kind of comment
Yeah.
bubble?
Yeah.
Yeah, there you go.
Okay.
Identifying X and Y intercepts. X and Y intercepts are where the lines cross over X and Y. To determine this point, set the opposite variable equal to 0 and solve the equation. If you're looking for X intercept, Y is going to be 0. So I'm going to use what I have there. So Y is going to be 0. So X to the third plus 1. Subtract 1. Okay, and then I want to find the cube root of X and the cube root of -1. Okay, what number times itself 3 times is -1?
1.
No.
-1.
-1. Okay, so it's going to cross over at -1, 0. So -1, 0. Then I'm going to find the other one. I'm going to set X equal to 0. So it is going to cross over at 0, 1. Okay, 0, 1. Right there would be my graph using my intercepts instead. Okay, again, review. X and Y intercepts. If I want to find X intercept, I set Y equal to 0 and solve. If I want to find my X intercept, I set Y equal to 0 and solve, and vice versa. I may have said the same one twice. Okay? How about symmetry? Symmetry is where a line or objects look the same on one side as they do the other. Like you could cut it right straight down the middle, fold it in half, and both of them will look the same. We talked about symmetry on page 60 and 61. Some of those graphs are definitely with symmetry. All right, here's the one thing you guys are going to learn today. You ready, Annette?
Yeah.
Okay. Circles. Okay? Everyone finished with everything that's on the board there?
Yeah.
Okay. Circles. We jump right into one thing we have not seen before, but it really isn't that difficult as long as you get and understand what what H and K, what they mean. Okay. So my circles, my standard form equation is X minus H squared plus Y minus K squared equals my R squared. H comma K is the center of my circle. Okay? Both H and K are the center of my circle. So it's the point that is there. You would probably think X and Y. Okay? But in this instance, because it's the center of the circle, we call it H and K. Okay? Same thing though. X and Y is a point on the circle. Okay, and r obviously is the radius. Okay? Go over and let's look at this particular one. It's on page 62, please. On 62, they give you a problem that has H and K as 1 and 3, and a radius of 4. Okay? And they want you to put that in standard form. Okay? So I don't have any x and y, so I'm going to leave x and y as the variable that's in there. So x minus h, which is 1 squared, plus y minus k squared equals 4 squared. Okay? How might I be able to get my answer there?
Do your PEMDAS, do your parentheses, all that stuff.
Okay?
So you get x squared and plus 1, y squared plus 9 equals 16.
Not exactly. If you look there, I think that they square root everything.
Oh, they do. You're right.
So if I square root everything, then I get rid of this, this, and this. Okay? So then I have x minus 1 plus y minus 3 equals 4. Do they continue on?
Well,
Or is that just, oh, they only want, They only want the
they
equation.
didn't square root the 4.
they
didn't square root the 4, or they didn't do that over the 4.
didn't?
No.
Okay.
Yeah.
Okay. They want just where you get the standard equation. I think of that one.
But
Hmm.
they didn't take any,
They didn't take the exponents
No, they
off.
didn't.
they didn't take the exponents off of that.
So that's a typo, that's gotta be a typo, right?
Okay, so maybe they want this.
But then, why didn't they take the exponents and all that stuff off there?
I don't know. It says to square each side, which is just exactly what we just undid.
I think it had the square root over it to begin with. And then,
Oh, maybe it did.
okay. Where the hell does square root come from?
Because it's undoing the r squared. See on the example 8, the r is not squared there. So to get them to be equal, I've got to square root the x minus h and y minus k. You're right, they started out with it to be square rooted, which I did not.
So that part of the equation, like the standard equation? Is it-
No, not necessarily.
They're not radical?
I would just stand with this,
Okay.
because that is the standard equation for a circle. You are going to be asked to do that on your homework quite frequently, okay? So I would definitely highlight this page so that you know that that square standard form of equation is right there, and it's in the box if you did not see that. Okay? Application. All right, so this is going to talk about mathematical models. Okay, hopefully you remember doing those last semester. The median recommended weights Y in pounds for men of medium frame from the age of 25 to 59 are approximately used with this mathematical model. Y equals 0.073 x squared minus 6.99x plus 289. And my numbers have to be between 62 and 76. Now, 62 to 76 is what x is going to be. Okay? We're going to replace x's with those numbers depending on the men's height. It says construct a table of values that show the median recommended weights for the men that are 62, 64, 68, 66, 68, 70, and so on. That would be a function table. Use the table of values to sketch the graph, and then use that graph to estimate how tall a man that is 71 inches would have to weigh. All right, so let's do 71 inches. Okay, using that particular mathematical model equation, okay, for x, I'm going to put in 71 because that is how tall the man is, 71 inches. Okay, almost 6 foot. All right, so take $71 and square it. What's 71 squared?
Well,
4,900.
50.
5,041.
Yeah.
5,041. Take that times 0.073.
369, or 367.993.
0.993. Okay, and subtract 699 times 71. 6.99 times 71.
Mine is 49629.
I got negative 128.297.
Well,
Yeah.
your 699 times 71 is 496.29.
71 times 6 would have to be 400 something.
So, and if we start off with 367, then we will have.
Oh, I just do this part, and then
Oh.
we'll put it all together.
Oh, okay.
So what did you get?
496.29.
29?
Yeah.
All right, so we're going to subtract 496 from 367.993 minus 496.29. What do you get?
Negative 128.297.
Plus 289.
160.703.
It's a 0.7. That's not very much. Almost 6 foot. You should weigh 160 pounds. What are we not taking into consideration?
Table.
His age.
Okay, maybe so. Absolutely. We do know that he's somewhere between 25 and 59. However, a 30-year-old is probably going to weigh a whole lot less than a 45-year-old. I mean, they get kind of dumpy in our 40s. If we haven't been dumpy yet. What else do we not take into consideration? BMI does not take this into consideration either.
Their lifestyle?
Lifestyle? Huh?
How they're built?
They're built. And this one does say a medium frame. It does not indicate what your bones are, how big your bones are, or your muscular shape. Okay? Those are two things that definitely do change a little bit. I'm kind of waiting for that to happen because, not that that's going to help me any, but it would be more accurate. Okay? When you see a young man like Talon, and he's 6'4", when you hear that he weighs 300 pounds, you think, whoa! Okay? But when you see him, he's not drastically overweight. He's pretty solid for his build. Okay? I'm sorry. I use you as an example a lot. So it does make a difference. Okay? If he was skinny, mini, no weight on him, he might be able to pull off the 6'4" with 200 pounds. Okay? But that is not his build. All right, how about linear equations? Linear equations with one variable. When you have one variable, you set the equation up to where the other variable is alone, and then you solve. So I want x's by itself, and I want the numbers by itself. And then I put them together. Because I have -6 here, I'm going to move the 6 over to this side. 3x equals 6. Divide by 3, and I get 2. Examples on page 67 of that. On page 67, we see fractions. Remember clearing the denominators? If you have issues with fractions there, use that. And it does show a clearing the denominator there with the 12. Because 12, 3 and 4 go into 12 there. So they multiplied everything by 12, and then you have whole numbers instead of fractions. That is clearing the denominator. Okay, and that is where I'm stopping today. We are going to start with quadratic equations on next week. You can go ahead and shut that off now. Thank you. On next week, we'll start with quadratic equations.